Okay, this is going to be a boring talk, not like the talk I had yesterday about measuring things and enabling scientific approach, like, try things, analyze the results, and proceed on the outcomes. So we need to do this because we're doing DevOps, or specifically continuous delivery, in order to deliver better software faster, which means heightened release agility without compromising quality. In general, what we want to measure, and we're not talking about operational metrics or business metrics. These are process metrics or flow metrics. So two things we want to measure across two parallels, velocity and quality. And the concept of flow comes from lean management practices, meaning basically the amount of change, amount of work we can move through our pipeline in a given unit of time. So how do we measure this? Well, there is no one recipe, but what we've come up is a set of 12 KPIs, 6 for velocity, 6 for quality, which I'm now presenting here. You can use them, you can comment on them. If you have your own, I'll be happy to hear. Okay, so here we go. We'll start with velocity. First of all, the most low granularity metric, which is mean lead time, which means how long does it take for a bit of code to get built, tested, and deployed. Then we've got the daily change rate, which means the number of changes getting committed to mainline and tested per day. Of course, it has to be tested, because if it's not tested and verified, it doesn't count. And then we have the mean time to environment, which means how long does it take devs or testers or whoever needs an environment to wait for an environment to come up. Of course, if we're already doing continuous delivery and everything is automated, this takes seconds, but we usually don't start at that point. Mean time to detect, which means how much time passes since the original commit of the code until the bug it introduced gets detected. Okay, very important. Of course, when everything is automated and we're testing things well, we expect this to be very fast. And mean time to resolve, once a bug got detected, how much time it takes us to resolve this. If we're very agile and we can react fast, this is a good thing. We're actually doing continuous delivery. And mean time to approve, how much time it takes us to verify and approve a release. Again, if we're doing continuous everything, this will be probably seconds, but we usually start with monthly, quarterly releases. And we need to be able to track if we're going in the right direction, if we're actually making this smaller and shorter. And now on to quality. Build failure rate, okay, how many of our builds are failing. This going up isn't necessarily a bad sign, because if we're doing more builds, probably more builds will fail. But anyway, something that's good to track. And also the deployment failure rate, different metric, but related. And, well, the failures by themselves are probably less interesting. What interests us is how many of those failures are related to infrastructure, such as things such as disk space, network, you name it. Important, and we have to put in this data. And rework rate, how much of our tickets are getting reopened, which means how good are we at testing what we do. Automated detection rate, okay, how much of our defects are getting detected by automated testing cycles. Again, once we have everything automated, this will probably be around 100%. This is the vision at least. Okay, and unplanned work rate, which means how good are we at predicting all kinds of unplanned shit. And then it becomes planned if we can predict it, of course. Okay, so where do we collect all this data? We, of course, start with project management tools, and then source control tools and CI server, and we need humans to input this data, because otherwise it won't be anywhere. And we need, of course, our tools to be integrated. We need to be able to track all our changes across all the tools. And where do we store the data? Well, probably ELK is a good place, or we can use Grafana as a dashboard for prettier graphs. And of course, we should communicate this on any of the knowledge sharing tools we're using, like Confluence or whatever else. And the important thing to remember that we're doing this not to put blame, not to point fingers, but just for the purpose of continuous improvement of what we're doing. Thanks.